Okay, this is looking like a more complicated exponentials question to that typically given, because we're given the formula p equals a r to the t, but you're normally given what a and r are, and we're not here. We're actually given some numbers that are the case. So work out the value of a. Actually, this is not quite so bad, and the fact that it's 1 mark, it makes life easier. The value of a is when t is equal to 0. Because that just gives you r to the power 0, which is 1, and hence p is equal to a. And so that's going to be the starting value. P is the population of the town after the start of 2018. This is the value of the population when t is equal to 0. So the value of a is going to be 1750. Show that r is 0.98. Well, when t is equal to 1, p will equal a times r, because r to the power 1 is just r. So when t is 1, this is when t is 0. This one here, a year later, is when t is equal to 1. So I can write down that 16,807 is equal to 1750. That's my value of a from before, times r. And hence r is going to equal, I can just solve this equation by dividing through by 17,150. Which is exactly 0.98. Brilliant. Okay, B is nice in some ways, because at least if we couldn't do that question, we've still got the value of r. If you couldn't work out the value of a, then you're in a bit of a tough place for question C. But I'm now going to write down the actual formula. So P is equal to 17150 times 0.98 to the power t. That's my actual formula with the numbers in. Show that the population is predicted to be less than 16,000 at the start of 2022. Well, if t is equal to 0 when at 2018, 2022 is going to be when t is equal to 4. $15,818. Maybe I'll just put a decimal point or two in, say 6.1. And this is less than 16,000. Finally, use the formula to work out what the population might have been at the start of 2017. There's two ways to think about this question. And I think probably the most natural is to think, right, if I'm timesing, so if I've got 17,150, that was in 2018, and then 2019, I've got 16,807, and what have I done? I've times by 0.98, and that's what I'm doing every time essentially. If I want to work out the population in 2017, then I'm going to do the opposite, or I would have times by 0.98 going this way. So going the other way, I'm going to need to divide by 0.98, and it's going to be 17,150 divided by 0.98. Which is 70,500. Another way we could have done it, and this is maybe it works, but maybe you're not quite happy with it. It's the idea, if t is going up by 1 every time, as the years increase, if I go back a year, I can actually minus 1 from the year, and I could have substituted in t is equal to 1 into this equation here. And then I would have got the same answer, in fact. But I think I like this way of doing it because it's a bit more intuitive, I think.